So for this last question, what we're doing is we're having a look at a lake and some water and some other stuff here. So tell us, a 300-meter wide lake has a buoy floating 200 meters from its leftmost edge. The buoy is held in place by a 45-meter long chain. Cross-sectional view is shown below. So this is the cross-sectional view: lake surface, buoy, chain, lake bed. Okay, determine the equation which models the shape of the lake bed. And then the next part there, with the onset of drought, the lake became shallower. If the same buoy is now held in place by a 30-meter chain, a 30-meter long chain, determine the new maximum depth of the lake. So what we're going to do, we're going to look at how we solve this thing. So my advice, take this and draw all over it using the information you've got. So no, Control Z, Control N, no, don't save, Control V. So here, what we're going to do, whoops, frustrating. No, it's happening again. Okay, if we can drag, I'll get a bit bigger. All right, so we've got this thing. So we've got 0 and 0. Whoops, there. We've got 300 and 0 there. And then here, we were told that it's 200 meters out, 200 meters from the leftmost edge, and it's 45 meters deep. Or the chain is 45 meters. So that means if this is, say, we're here at 200, and if this is 45 meters in depth or in length, or whatever it means, then here we must be at negative 45. So that's what we've got there. Now, first question. So we've got our two x-intercepts, and also we've got another point here. There's 0, 3 points. So with this, what we do is we use factor form. So we're going to determine the equation. So in case, calculate, we know we've got a times x minus b, x minus c. Whoops, shouldn't be a v, should be a c. C. Why has it done that? Something must be stored in v. Anyhow, that's what we've got there. So what we're going to do now is we're going to substitute our values. So we've got x, so we've got a 1 of 0, another one of 300, so that's what we're going to put in there. So we're going to say x minus 0, x minus 300, and that's what we're left with. And then we're going to use this other point here, and we're going to substitute that in. It's good when random stuff just beeps. Okay, so we're going to take this information and we're going to solve. We're going to solve for a. So solve this equals, so we're looking at this here, 200 instead of x, negative 45 for our function. Equals negative 45, and instead of x, we're going to write 200. We are solving this for a. A is 9 on 4,000. So our equation becomes that. Now, we may want to write that in general form or something, so we can say expand that, and we end up with that. So that's our expanded version. Lots of different ways we can run it. Can we factorize it? Factor. So there's a factorized version, as much as this can factorize. So that's what we've got. So we've got our function there. There's so many equations. So that's the equation there. It's got to be in terms of x, because we've got x here. We don't have anything here, but this might be d of x for depth. It may be y, height, I don't know, but we've got x. That's all we need. That's all the information we've got. So with the onset of drought, the lake became shallower. If the same buoy now held in place by a 30-meter long chain, by a chain 30 meters long, determine the new depth of the lake. So it's only become shallower. Hasn't become narrower. I don't know why. Although it's become shallower. I don't teach physics. Melbourne Uni wouldn't let me. But in this case, it only becomes shallower. So let's have a look at our graph. So now instead of 45, we're going to change this. We're going to make this still happening at 200, and it's happening at negative 30. Oops. So that's what we've got there. So we're going to do like what we did before. So we're going to take this thing. So we know this is our equation, except what we're going to do is we're going to complete the square if it lets us. Complete square. Hopefully it works for x. Alright, so that's what we've got there. So our minimum happens at 150, makes sense. If we're halfway between 0 and 300, we've got 150, and it happens at negative 405 minus 8. Sorry, negative 405 over 8. Now, instead of this, what ends up happening is that our new, hang on, so that's our current minimum. We want to find the new maximum depth. Okay, so what we've got to do, we're basically rewriting our equation. Got a little bit ahead of myself there. So what we're doing is instead of, so we've got this thing, and instead of 45, it's not 45 anymore, it's 30. Everything else is still the same. Here's the good thing about CAS, we can just press the up arrow button. We've got that, so that's our new value of A. So what we're going to do is we're going to write, we're going to take this, we're going to delete this, all this here. Oh no, we don't want that. No, sorry. Here is our equation. That instead of A, we're going to write this. And so we've got this. So that's our new equation. Now we want to find out what our new maximum depth is, so we're going to complete the square. On this, for x, so our new maximum depth is negative 135 over 4. Let's just check it just to be sure. So we're going to make a graphing page, and we're going to say, oops, control left. We're going to graph the first one, which is this. We know our window has to go from settings, go from -1 to 305. Our y has to go from negative, say, 50. And we know it's going to be at least 50. We'll go maybe 80. And a y maximum of, say, 10. So that's what we're looking at there. There's our lake. Now our new one. That's what we've got there. We're going to graph that thing as well. So we can check. So we've got the same intercepts. We've got the same kind of deal. Now, so we had our original minimum. Actually, no. We want a graph at, so we want to check this. So I'm going to put in a line at negative 45. So that's our original. That should be at 245. So 200 negative 45. Look at the intersection. That graph and that graph between there. So we're at 200 and negative 45, which is fine. And then we're going to have another one. I'm going to say at negative 30. Look at the second graph. Analyze intersection between the red and the pink. It's happening at 200 and negative 30, which is exactly what we want. So that works. So we want our new maximum depth. So we want to know this. Now, according to CAS, it is negative 135 over 4. Let's check. Menu, analyze graph. We're after a minimum. That one. Lower boundary, upper boundary happens at 150 and 33.8. So let's just check that, if that makes sense. So we'll say 135 over 4.0. 135 over 4.0, 33.75, close enough. So for this one, we could do that, or we've got it there happening at 150. We just know that we've got it at 150 there because that's when it should be. So we substitute 150 into this and we end up with 33.75. Now, 33.75 is an exact answer. That's fine. So what we would say is that onset of drought labour control, new boy chase, so chain was 30 meters long. Determine the new maximum depth would be 33.75, I think. Yeah, 33.75 meters is our new depth. We won't write negative because we don't have a negative depth. We just have a depth of 33.75 meters. If we said negative 33.75, then we'd have a problem because it'd be 33.75 meters above the water. That doesn't work. So just to recap that. So we wanted to find out the equation. So we had our factors, a, x minus b times x minus c. We substitute our two factors of 0 and 300. We end up with this. We solve. We substitute our x value and our y value that we were given. We solve a, we rewrite that. Then, same deal, except we had the same thing, so we've still got our situation changed. Depth is different, it's having the same point, so 200, 200, and negative 30. Once again, we solve for a, we put that in, we write it in turning point form to find the new maximum depth. And that's all that we have to do.